As you may know, OSHA has released a new rule about silica dust. Here at Pulse-Bac, we've gone through the rule and have made this video to help you understand what this may mean for your work. The first thing to understand is where you might encounter silica dust on the job site. Crystalline silica is generally found in concrete, brick, and stone products, as well as man-made stone and other masonry materials. This means the rule covers a pretty large group of trades, from roadwork to decorative concrete to countertop installation and more. Due to health issues related to silica dust, OSHA has reduced the permissible exposure level, or PEL for silica dust, to 50 micrograms per square meter on an 8-hour time-weighted average. So what does all this mean? The 8-hour time-weighted average part is too complicated to get into here, but what can be said simply is the new standard is basically 1/5 of what was previously allowed for construction. OSHA is issuing two standards, one for construction and the other for general industry and maritime. In this video, we'll be focusing on the construction standard. The rule provides two options for construction. Option 1 is, in short, to control the dust with your own measures, then measure the amount of silica dust to which workers are exposed. If it's at or above the action level of 25 micrograms per square meter over an 8-hour time-weighted average, you must find better measures to protect workers from crystalline silica dust exposure. Option 2 is to simply follow the dust control methods in Table 1 of the construction standard. Measuring PEL can be complicated. It involves placing special monitoring devices on workers and then sending the monitors off to a laboratory for testing, and/or providing medical testing for workers on a regular basis. So basically, you have to say, I've got my own way to control the dust, then take the time and expense to test your idea. If your idea works, you're set. But if not, you start all over again until you get it right. For many businesses, this isn't going to be very practical, and that's why Table 1 may be the better option. So let's look at Table 1. Table 1 shows dust control methods for many common job site operations. According to OSHA's fact sheet, employers who follow Table 1 correctly are not required to measure workers' exposure to silica and are not subject to the PEL. For tools like stationary masonry saws, hand saws, walk-behind and drivable saws, rig-mounted core saws, or drills, Table 1 requires the use of a tool equipped with an integrated water delivery system that continuously feeds water to the blade or bit. And this is almost always followed up with the instruction to operate and maintain the tool in accordance with the manufacturer's instructions to minimize dust emissions. Other tasks have different requirements and options. Things like cutting fiber cement board, tuck pointing, dowel drilling concrete, and using handheld and stand-mounted drills must use a commercially available dust route and a dust collector. For jackhammers and chipping tools like hammer drills, handheld grinders, walk-behind milling machines, and floor grinders have the option of using a water delivery system or a dust collector for less mess. Along with the requirement for using a dust collector in many of the operations, Table 1 also places requirements on the dust collector itself. The following statement appears in the table almost everywhere a dust collector is called for. Quote, the dust collector must provide the airflow recommended by the tool manufacturer or greater and have a filter with 99% or greater efficiency and a filter cleaning mechanism. To more clearly define what that statement means, we'll look to the text preceding Table 1 to gain some insight. Let's first take a look at what is written about filter efficiency. It shows us that OSHA had originally considered requiring HEPA filters, which provide a filter efficiency of 99.97% at 0.3 microns, because they believed they offered better protection from silica dust. However, they found two things. One, too many HEPA filter vacuums will clog quickly, making the level of filtration irrelevant. And two, there were far more filters that were close to HEPA available, so the standard could be more easily implemented. At Pulse-Bac, we do feature HEPA filters in all of our units as we feel they provide the best protection for our customers. Though admittedly, we do have the advantage of our patented automatic pulse clean technology, which makes clogging a non-issue. So, when you're looking at filtration from a compliance standpoint, while a HEPA-rated filter will provide more protection, your only obligation is to make sure that the filter provides at least 99% filtration. Now let's look at the second part of the requirement, that the dust collector be equipped with a filter cleaning mechanism. A filter cleaning mechanism could really mean a lot, so we need to look at what the expectation may be behind this statement. Here again, we need to turn to the body of the text to help shed some light on this. In the body of the text, you'll see that when looking for solutions to capture dust, OSHA quickly discovered that the fine dust most materials produce would quickly clog standard vacuums. First, there's a statement regarding data they looked at from NIOSH, and that is, quote, NIOSH pointed out that a reverse pulse feature on a dust collector should preclude the need to remove filters for cleaning. OSHA agrees and has included the specification for a filter cleaning mechanism. When looking to define what is expected as far as the function of the filter cleaning mechanism, the following statement gives some insight. Quote, "The filters on a vacuum must be cleaned or changed as frequently as necessary in order to ensure they remain effective. It may be necessary to activate a back pulse filter cleaning mechanism several times during the course of a shift. And regular stops to conduct the proper reverse air pulse filter cleaning procedure were crucial to successful dust control." Then in a different section we find the statement, "To assist employees in determining when it is time to run a filter cleaning cycle, vacuums equipped with a gauge indicating filter pressure or equivalent device, e.g. timer to periodically pulse the filter, may be useful." So here it becomes clear that filter cleaning will play an important part in compliance. And as we can see from the last statement, dust collectors will have to be monitored and filters cleaned frequently to do this. Other tests we've seen show that vacuums can lose up to 50% of the airflow as the filter clogs, and depending on the material, this can happen quickly. So under real-world conditions, to stay within the requirement, filter cleaning mechanisms and monitoring equipment will have to become fairly regular on the job site. The other option, as it says, is to purchase a vacuum with an automatic filter cleaning mechanism. This eliminates the need for monitoring and work stoppage to manually activate the filter cleaning mechanism. Table 1 is available to view at OSHA.gov/Silica. Just look for the link in the upper right-hand corner. The rule is slated to go into effect June 23, 2016, and construction businesses are required to be in compliance by June 23, 2017. Hopefully this video has given you a better sense of what you may need to do to keep yourself in compliance.